This is Lecture 2, Collecting and Measuring Data. By the end of this lecture, you should be able to understand how to construct a conceptual definition of a variable, understand how to construct an operational definition of a variable, understand how to evaluate the validity of a variable, and understand how to evaluate the reliability of a variable. In the previous lecture, I briefly reviewed the basic steps in conducting a statistical analysis in political science research. Before I go into more detail on how to conduct statistical research in political science, first I need to teach you how to measure concepts and variables. If you do not know how to measure concepts and variables, you will not be able to conduct any statistical analyses. Hence, this lecture is all about collecting and measuring data. Political scientists study concepts such as liberalism and conservatism, and equality and inequality. These concepts are not tangible. You cannot touch them or hold them in your hand. You cannot see them. You cannot hear them. Nevertheless, we know these concepts exist. They exist as mental constructs. Since these concepts are mostly mental constructs, we have to make sure we have a good definition of what they are if we want to measure them and collect data on them. For example, we may have a general idea of what war looks like. Two states may use physical force against each other. They may destroy each other's property. There may be battle deaths. However, not all conflicts between states are wars. Sometimes two states will have a single battle in a single day and the conflict will end. Is a one-day conflict a war? Not really. So how do political scientists distinguish between wars and short-term conflicts? One way is to use battle deaths as a criterion. The Correlates of War dataset classifies any conflict between states with 1,000 or more battle deaths as a war. In this lecture, I will show you how to define concepts so that they are measurable. In order to measure a concept, we need to develop a more concrete idea about what the concept means. The first step in this process is developing a conceptual definition of the concept. A conceptual definition first includes the unit of analysis. The unit of analysis tells us who the concept applies to. Is it individuals? Is it parties? Is it countries? Or is it pairs of countries? It also tells us where these individuals exist and when they exist. Going back to the war example, the unit of analysis would be pairs of states, like the US and Mexico in 2012. These pairs are called dyads. If you ever take an upper division course in international relations, you will talk a lot about pairs of countries or dyads. The conceptual definition also identifies a concept's measurable properties that we can observe in the real world. Going back to the war variable example, we can observe how many battle deaths there are in a conflict between two countries, which allows us to determine if a conflict between two countries is a war. If there are 1,000 or more battle deaths, we would say there is a war. If not, we would say it's not a war. The second step in collecting data on a concept is developing an operational definition of the concept. The operational definition tells us specifically how the concept is measured. To do this, the operational definition first tells us what values the variable takes and what those values mean. For example, for our war variable, it would take on a value of 0 for non-wars between states, less than 1,000 battle deaths, and 1 for wars between states, 1,000 battle deaths or more. The operational definition also tells us where we got the information to measure our variable from. Based on this information, we would know whether our variable was collected using primary data or secondary data. Primary data is data we collected, and secondary data is data someone else collected. Going back to the war example, if we collected data on battle deaths, we would probably use government documents and news reports to measure battle deaths. Our variable would then be considered primary data since we collected it. Of course, we could just use the Correlates of War dataset as a secondary source, as the authors of the Correlates of War dataset already collected the data and coded wars and non-wars for us. In the next few slides, I will show you how to develop a conceptual definition. As an example, we are going to develop a conceptual definition of democracy. The first step in creating a conceptual definition of a variable is to identify the variable's unit of analysis. Recall that the unit of analysis tells us who the concept applies to. Is it individuals? Is it parties? Is it countries? It also tells us where these individuals, parties, countries exist and when they exist. Going back to the democracy variable example, I decided that we are going to develop a conceptual definition of democracy for countries in the world in 2017. Countries throughout the world in 2017 is the unit of analysis for the democracy variable. After you determine your unit of analysis, you can classify the variable you will eventually collect as either a case study, cross-sectional, time series, or cross-sectional time series variable. This chart here can help you determine what type of variable you have. If your variable only applies to one subject, and you only have a few observations for that subject, then you have a case study. An example of this would be studying democracy in the United States in 2017. There would only be one subject, the U.S., with a couple of observations in 2017. If your variable only applies to one subject, but you have multiple observations for that subject over time, then you have a time series variable. An example of this would be studying democracy in the United States between 2001 and 2017. There would be only one subject, the U.S., with multiple observations between 2001 and 2017. If your variable applies to multiple subjects, and you only have one observation per subject in a given year, then you have a cross-sectional variable. An example of this would be studying democracy in all countries throughout the world in 2017. There would be multiple subjects, all countries in the world, with one observation in 2017. If your variable applies to multiple subjects, and you have multiple observations per subject over time, then you have a cross-sectional time series variable. An example of this would be studying democracy in all countries throughout the world from 2001 to 2017. There would be multiple subjects, all countries in the world, with multiple observations each between 2001 and 2017. Going back to the democracy variable example, our unit of analysis was countries throughout the world in 2017. In our variable, we would have observations for multiple subjects, all countries in the world, with one observation each in 2017. This would make our variable a cross-sectional variable. The next step in developing a conceptual definition is identifying the concept's measurable properties. These are properties we can observe in the real world. For example, if we were writing a conceptual definition of democracy, the measurable properties of democracy can include whether a country has elections, whether leaders of a country are held accountable for their actions, and whether the country has a highly developed economy. These are all potential properties of democracy that we can actually observe in the real world. After we identify the concept's measurable properties, we have to modify our list just to make sure we are only including relevant and measurable criteria in the list. For example, in our previous list, elections and accountability were good measurable properties, because all democracies should have elections with elected officials who are held accountable for their actions. However, we should leave out the economic development property. Economic development is not an inherent property of democracy. As long as a country has elections and leaders are held accountable for their actions, it is a democracy. Its economy does not have to be developed. A country could be a poor democracy. After we modify our list of measurable properties, we write down our conceptual definition. You can use the following template to write down a conceptual definition. The concept of X is defined as the extent to which subjects exhibit the characteristics of Z. So using our democracy example, we would write, the concept of democracy is defined as the extent to which an individual country holds elections and holds leaders accountable for their actions. Next, we will discuss how to develop an operational definition. Recall that an operational definition tells us specifically how the concept is measured. The first step is to establish the specific observable criteria for your variable. For example, if we were measuring democracy and we wanted to measure elections, we would specifically examine whether a country has free and fair elections, where every adult can participate and the rules do not favor one party over the other. In addition, we will want to make sure leaders are held accountable. One observable and measurable way leaders can be held accountable is having to face re-election at fixed intervals. The next step in creating an operational definition is identifying the values your variable will take. For example, with our democracy variable, we can make a rule that when we identify a country as democratic, we can give it a value of 1, and all other countries will receive a value of 0. The third step in creating an operational definition is identifying your data sources. Your data sources tell you whether your subjects meet the specific observable criteria in your variable. We can either use data we collected, which is called primary data, or use data that other people have collected, which is called secondary data. If we wanted to collect primary data, we could use information from news reports, government documents, surveys, or experiments. There are lots of places we can collect data from. Of course, there are a ton of political science-related data sets out there that other scholars have already created, so often it is just easier to use data other people have created instead of creating our own. So in our previous example, we stated that we would classify a country as democratic if it had free and fair elections where every adult can participate and the rules do not favor one party over the other. In addition, leaders in the country have to face re-election at fixed intervals. We could use the CIA World Factbook as a data source in this case to determine if different countries throughout the world meet these two criteria. The variable we created would be a primary source as we collected it. After we collect our data, we have to review our variable to make sure we are measuring what we want to measure. A variable is valid if it measures the concept it intends to measure. It is invalid if it does not measure the concept it intends to measure. There are several reasons why a variable may be invalid. For example, systematic measurement error occurs when we create an operational definition that consistently mismeasures our concept for a specific reason. One reason could possibly be that the variable measures more than we think it measures. For example, going back to our democracy variable, we said we would use data from the CIA World Factbook to determine if countries had free and fair elections and leaders were held accountable for their actions. If the CIA World Factbook is an unbiased source of information of countries throughout the world, the information it gives would allow us to collect a valid measure of democracy throughout the world. However, if the CIA World Factbook is biased in such a way that it is less likely to publish unflattering information of U.S. allies, then our variable may lead us to code some non-democratic countries that are U.S. allies as democracies. Then our variable would not only be measuring democracy, it would also be capturing U.S. government bias of countries throughout the world, a characteristic we did not intend to measure. U.S. bias would be causing systematic measurement error in our measure. If that happens, then our variable would be invalid. The solution to this problem is to find an unbiased source of information to code our variable. The Hawthorne effect also leads to systematic measurement error. The Hawthorne effect occurs when you are collecting data from individuals and those individuals behave differently because they are being observed. For example, we know that when survey researchers ask respondents questions about race-related issues, the race of the survey researcher and the respondent matter. African American survey respondents are more likely to say that they face discrimination when an African American survey researcher asks them questions about discrimination versus when a white researcher asks them questions about discrimination. Hence, the survey questions are not only capturing African American attitudes on discrimination, the intended characteristic, they are also capturing social pressure, an unintended characteristic. The solution to this is to have survey respondents fill out a paper survey that is confidential so they don't feel pressure to answer a certain way based on the characteristics of the survey researcher. The way we code our variable could also lead to systematic measurement error. Recall that we coded non-democracies as 0 and democracies as 1. It is easy to classify countries that are purely democracies or purely non-democracies, but there are several countries throughout the world that are not clearly democratic or non-democratic. Russia is a perfect example. There are elections in Russia, but leaders are rarely held accountable for their actions. Should Russia be classified as a democracy or not? It is a tough question. In order to overcome this problem, we should probably go back to our operational definition and refine it. We could add another category to the definition. Democracies could be coded as a 1, mixed systems could be coded as 0, and non-democracies could be coded as -1. Another threat to validity is the ecological fallacy. An ecological fallacy occurs when you collect aggregate level data and apply it to individual level behavior. For example, we know that at the individual level, low-income voters are more likely to vote for Democrats, while high-income voters are more likely to vote for Republicans. However, when we look at the data at the state level, low-income states tend to vote for Republicans, while high-income states tend to vote for Democrats. This is known as the red state, blue state paradox. The paradox demonstrates how we cannot apply the behavior of all voters in a state to the individual voters in that state. To demonstrate how this happens, I created 2 hypothetical states. First, there is a poor state with 80 poor voters and 20 rich voters. As you can see, the poor voters are more likely to vote for Democrats, 44 to 36, while the rich voters are more likely to vote for Republicans, 4 to 16. However, when we add all the votes together, there are more votes for Republicans than Democrats. So this poor state voted for the Republican candidate. Next is the rich state example. In this state, there are 80 rich voters and 20 poor voters. As you can see, the poor voters are more likely to vote for Democrats, 16 to 4, while the rich voters are more likely to vote for Republicans, 36 to 44. However, when we add all the votes together, there are more votes for Democrats than Republicans. So this rich state voted for the Democratic candidate. The way to avoid the ecological fallacy is to collect data at the individual level instead of the aggregate level. In this case, it is better to collect data on individuals' incomes and their individual voting behavior rather than looking at average income and average voting behavior at the aggregate state level. There are several different ways we can evaluate whether a variable is valid. We can use the face validity test, where we simply look at how a variable is coded and think deeply about whether it is logically coded. For example, we could look at our democracy variable and think deeply about whether there may be reasons the variable might miscode some cases. We already did this when we discussed threats to validity in the previous slides. So for example, we talked about how it could be possible that the CIA World Factbook was biased and could lead us to miscode some non-democratic U.S. allies as democracies. If this is the case, then the democracy variable would fail the face validity test and would be considered an invalid measure of democracy. We could also use the construct validity test, where we see if our variable is related to a variable that it should be correlated with. So for example, we could compare our democracy variable to a human rights variable, as we know that democracies are more likely to have good human rights practices than non-democracies. If we compared our democracy variable to a human rights variable, but discovered that the two variables were not correlated, our democracy variable would fail the construct validity test. Not only do we need to evaluate whether our variables are valid, we also have to evaluate whether they are reliable. A variable is reliable if it consistently measures subjects or cases the same way when we apply our coding criteria to those cases multiple times. Using our democracy variable example, the variable would be reliable if multiple coders coded the same countries the same exact way. A variable is not reliable if it does not consistently measure subjects or cases the same way when we apply our coding criteria to those cases multiple times. Using our democracy variable example, the variable would not be reliable if some countries were coded differently by different coders. One threat to reliability is when you have multiple coders coding a variable and they sometimes have to make judgment calls about how to code a particular observation. So for example, one of the coding criteria for the democracy variable was whether a country's electoral rules do not favor one party over the other. This is not an objective criterion, it's subjective. As such, two coders might disagree over whether a specific country's electoral rules favor one party over the other. If that is the case, one coder may code a country as a democracy and the other might code it as a non-democracy. One coder would clearly be correct and the other would not be. As a result, the democracy variable would be an unreliable measure of democracy because sometimes it measures democracies and non-democracies correctly and sometimes it does not. There are several different ways we can evaluate reliability. One way is the test-retest method. In the test-retest method, we apply the coding criteria from our variable to the same subjects repeatedly to make sure the variable produces the same coding outcome every time. When we have multiple researchers coding our data, we can use an intercoder reliability score to make sure the variable produces the same coding outcome for each subject in our dataset, regardless of which coda is coding the data. A simple intercoder reliability score is the percent agreement measure. It is calculated by dividing the total number of cases the coders agreed upon divided by the total cases multiplied by 100. So in this example, coders 1 and 2 agreed upon the coding for country A, country B, and country D. The percent agreement measure would be 3, the total cases agreed upon, divided by 5, the total number of cases, times 100, or 60%. If you do find that a variable has a low intercoder reliability score, one solution is to have a principal investigator make the final coding decisions for observations that are coded differently by different coders.